Good morning, dear students. In the last two sessions, we have gone through the different phases of compiler, mainly translators. Now, in this session, I want to present the lexical analyzer phase, totally the first phase. Okay, and as part of your academic syllabus, the first unit consists of the introduction part of your compiler design subject, and the second part is totally the lexical analyzer. Okay, lexical analyzer, the main contents are role of lexical analyzer and the related concepts. How a lexeme, what is a lexeme? How a lexeme is observed. That is what each and everything we can observe. My dear students, the first concept is role of lexical analyzer. Role of lexical analyzer is mainly to read the input character stream and to generate the token stream. That is the output of lexical analyzer. Okay. So here the one thing is actually the entire task of a scanner means lexical analyzer. Scanner should be initiated by the parser. Parser means the syntax analyzer has to initiate the task of lexical analyzer. Is it clear? So, how it initiates the task means simply with one command, that is get next token command. Actually, in its routines, in its functions, it possesses that command get next token command. Means what? The syntax analyzer asks for the token. Yes, give me one token. And like this it asks the lexical analyzer. Then lexical analyzer starts its process. That is nothing but reading the characters and the preparation of the tokens. It prepares one token and it gives it to the syntax analyzer. That is as a command it hits with the command and the output is one token. Right? Now, how it performs that task? That is the major role of a lexical analyzer. The role of a lexical analyzer is. Okay, right? So, the main goal of lexical analyzer is it reads the characters with the command get next token command by the parser, and it performs each and every different internal defined tasks, and finally it is able to produce one such token. This is nothing but the main role of a lexical analyzer. Is it clear, ma? Here you should one point you have to remember, that is how is it able to identify each and every character streams means it has to group it, it has to have some input information. So how it maintains that input information and in what way it performs means mainly in 3 steps it performs. First it reads the characters, that is scanning. That is how the another name of lexical analyzer is a scanner. Okay, right? So in the scanning it reads one character and it analyzes it and reads one another character, like this group of characters. If it is getting any meaning, meanwhile it matches with the defined patterns, tokens in it. The defined pattern information. How this pattern information is going to be represented in lexical analyzer means that is mainly with the help of regular definitions. There you will use the concept of a flat. Okay, right? Finite automata. With the help of regular definitions, with the help of regular expressions, you can define you can give the input information. Yes, this is the pattern of identifier, this is the white space and this is the digit, and like this each and every programming language construct you can easily represent with, okay, regular expressions. Is it clear now? So it possesses some input prior information. With that input prior information, these character streams are going to be analyzed and it prepares such information and it priorly stores that information into the another item that is connected. You can observe in the figure another item that is connected to this point. What is that? Tell me. Yes, that is nothing but the symbol table. It stores this prior information into the symbol table. Symbol table is a data structure. Symbol table is a data structure. In the form of rows and columns, it maintains the data of user defined data only it maintains. In your C language, you can give it as int A, int B, like that you can. So what is that way? You are defining one variable as an integer, right? So that variable name is A, and you are defining one variable, that variable name is B. So these two are nothing but the identifiers. Okay, ma? There you can easily observe the information related to the user defined data is stored in symbol table in our example, that is A and B. Okay, is it clear now? Right? So this is what the entire the tasks of lexical analyzer. First, it must have that prior information with the help of regular expressions. The definitions of each and every pattern, this is the pattern according to the programming language constructs, it maintains such data within it, and it reads the characters. Whenever it just gets the get next token command, simply it performs the task, and it groups that characters data. That one item is known as lexeme. Is it clear, ma? That one item is known as lexeme. So that is what? First, identification of the lexemes with the input information, and identification of patterns. So which pattern this lexeme comes under, right? And the next one is nothing but the preparation of the tokens and give it as an output. This is the role of lexical analyzer is. Now, why do we separate the lexical analyzer role with the syntax analyzer? Actually, the role of lexical analyzer should be initiated by the parser. So you can combine it as a single phase. What is the main need? You will prefer it as maintaining it as two different phases. Can't you maintain it as a single phase? Yes, you can. But here it increases. If you maintain it as a single phase, the complexity of the design is more tedious task. So for the simplicity of design sake, we will divide it as two different phases. Okay, ma? Right? Two different phases. You can observe it as two different phases. For the one such benefit is nothing but the design task will be so simple. Okay? That is one of the reasons you can observe in the slide. And the second reason is you can improve thereby just by differentiating these two tasks as two separate roles, the efficiency can be improved very much extent. These are the major benefits. Okay, the major benefits just by with the main need to separate the lexical analysis phase and to the syntax analysis. Is it clear? This is the main purpose that you'll divide these two as the two different phases. And coming to the tokens. What do you mean by a token? What do you mean by pattern? Which one is a lexeme? Lexeme means simply just it greets the characters and make it as one group like. That's it. That is it. Which group? Yes, there comes the matter. That is what? It must under any predefined patterns. Any one of the predefined patterns. So that lexeme must come under any one of the patterns. Okay? Is it clear? So that is nothing but the lexeme and patterns. What do you mean by pattern? That is what? According to the programming language construct, it allows certain predefined data, reserved words and the prior data types and some sort of integers, identifier rules according to the rules of the programming language construct, it allows. That is defined nothing but the pattern. And what do you mean by token means? Yes, token is nothing but there is no more programming language rules you won't use here. According to the phases terminology wise, just you will use the token, one token. Simply if you want to purchase any goods, then you'll get that number of tokens that you will get simply. That is what that shopping malls maintains such sort of maintenance tasks like. So that is how our compiler also, that is so smart, which maintains it as one token form. Within two angular brackets you can represent that token attributes. Okay, so this is nothing but the tokens, patterns and lexicons. Coming to the examples, my dear students, you can see the examples of the tokens. Suppose consider the first example, if. You know very well, if is according to all high level programming languages, it allows if. So the first character is I and the next character is F. It treats I first and F next and it groups it. Whenever it just reads the next symbol and then it identifies that up to the previous symbols are nothing but one group, one such group. Then that group is nothing but one lexeme. That lexeme is IF. Then it finds it out in its patterns definitions with the help of regular definitions, pattern definitions. Then here, is there any meaning for IF or not? Yes, it found that, and this is a predefined the reserved word. So in such a manner, each and every statement is going to be observed, analyzed. Is it clear now? So these are the examples of tokens, patterns and lexemes. Then attributes of tokens. What are the attributes of tokens? Yes, the prior information. This information should be utilized by the lexical analyzer. The lexical analyzer has to give that information, and that information is used in all around all the remaining phases in the compiler. So the token must possess its own attributes. Okay, the first attribute is token name and the second attribute is token value. Okay, so whenever if you want to represent any information, suppose if you want to represent one ID comes under the ID pattern, then there you can simply give it as ID 1, 1. What is that one? Yes, that one makes you, that one is nothing but a pointer which points to the related data which is stored in symbol table. Is it clear now? Yes, this is what nothing but the tokens examples. Is it clear? My dear students, the very much important concept here is some sort of by mistake user may enter instead of first giving I in the if keyword as first as F I making by mistake. Then lexical analyzer, in what way it thinks about that F I means one, that is that comes under the pattern of an identifier rules. That is not reserved word. So there the point is it comes under, it just treats it as, but you are according to your terminology that is an if keyword, if reserved word, right? So these are the problems may arise. So that is brilliantly the lexical analyzer is designed because of, we can say very proud, we can put up our designs because it thinks internally, maybe it just replaces with I as F and F as I. Simply it recognizes that yes, by mistake he has entered F I, but this is I F. Yes, these are the problems will arise. So for this, it is having, lexical analyzer is having its own error recovery mechanism. That error recovery mechanism is panic mode error recovery. Okay, ma'am? Panic mode error recovery mechanism. In panic mode error recovery mechanism, it performs either deletion of certain characters, single characters, or transposition of any two adjacent characters, or inserting a new character in between, or just discarding the previous information that just it has read. So like this it performs certain predefined rules have been there. This is all internally each and every phase of compiler possesses the error routine mechanisms. Here it uses such error routine mechanism as panic mode error recovery mechanism. Okay, with the help of that, even these small simple typing mistakes are also can be corrected with lexical analyzer error recovery routines. Is it clear? Right? So this is all nothing but the role of lexical analyzer and the definitions of tokens and patterns, and simply the lexical error. What is a lexical error? And this error recovery mechanisms. My dear students, please go through the very important number of times these questions have been asked in your previous exams. So these questions are very important. Please go through these questions, okay, and please read well thoroughly, do well and do good. Thank you.